I'd like to introduce my friend Peter Thorne from Kombashi for the opening talk.
Okay, so I'm delighted to have the chance to present some results of some Kombashi research and some Kombashi market data. Now, the data sets I'm going to be using are the most recent releases, which means that for us, 2017 are actual data, 2018 and beyond are forecasts, which I suppose makes sense, actually. If they weren't forecasts, I'd have suggested the nature of the content of this presentation should be about time travel, but yeah. Okay. Right. So, there seem to me to be more signs of the tectonic plates of the marketplace, more signs of them moving than ever before. On the technology side, hands up who's seen a Trimble Microsoft HoloLens hard hat. If you haven't seen it, look at the website. It's great. You put on a hard hat, it's got dark glasses integrated in it. They're not dark glasses, they are actually a HoloLens. And if you've been connected and calibrated, you look up at the ceiling of the shell of the building that you're in, and you see the AR representation of the air conditioning that you're about to install. And it's presented as a hard hat. And the people in the video appeared to be real construction guys, and they seemed to want to wear this thing in order to be able to see what the architect's plans. And also, what about ANSYS Discovery Live? Has anyone seen that? Yeah? We've been talking about parallel processing and GPUs for simulation. ANSYS have done it. They've brought these things together so that direct modeling of mechanical parts and simulation are happening interactively. But rather than technology, I think it's also important to look at what's going on in industries. So automotive, maps. We had a consortium of German car companies buying the HERE Nokia mapping system. Mapping becomes a component of cars. They don't just need wheels and powertrain and bodies and so on. They need maps. Software platforms. No surprise that Renesas put together a software platform for cars. Samsung put one together. And as I understand it, Renesas was the walled garden, the Apple-like, it's all safe in here, it all works together. And Samsung did the Android equivalent of, rather more open, but, there's more that you've got to sort out for yourself. And that's no great surprise. But then what about Mentor, who also announced DRS 360 just maybe a month or two ago? And that's a software company from our industry of engineering software, product development, tools for product development, also announcing a platform for cars. And okay, well that's one thing, but look a bit further afield, and the Chinese internet giants are also active in this area. So Baidu have a system called Apollo, and Alibaba have a system called UNOS, which they describe as car operating systems. And they have a real interest in this from their point of view. All the screens in the car are just like all the screens in any other consumer device. They want that to be part of the environment that they're looking after for whatever sort of infotainment or advertising or whatever it could be. Move on. Electric vehicles and charging. Who's going to do that? Well, it's a natural intersection of automotive and power, I suppose. But look who's getting involved. Ford and Daimler and Volkswagen and BMW got together in the Ionity joint venture. So you think, fair enough, they don't run petrol stations, but maybe EV charging is sensible for them to do. But in addition to that, Shell bought New Motion. And at the time they had or were claiming 30,000 home charging points and 50,000 public charging points. So, it's a place for the oil industry as well. And Total bought Pitpoint. And Pitpoint were interesting because they mix EV with natural gas, liquid gas refueling. So let's move on. Automotive, building automation. Now, I'm not trying to do a survey of these sectors. These are just little snippets to give you a feel for what's changing. Kone and IBM offer machine conversations. You can go to the website and that they use for promotional purposes. Kone, make a big deal of the fact that their elevators have 200 data points that they're monitoring all the time. And to publicize this, with IBM Watson, they've converted this data sensing into something that you can watch. And you can see the conversations, okay, they're presented in natural language, of elevators around the world, telling you about where they are, what speed they're doing, what vibration there is, they detected on the last move, and a central server reporting back, saying, that's fine, vibration within limits. They've done the same thing for escalators. There's a Twitter feed at just an escalator. And that will, well, actually, I don't know about you, but it seems, sort of slightly disturbingly intimate when an escalator actually tweets to you and says that its gearbox temperature is 38 degrees. I don't know, it's just a bit strange. It hasn't said anything about the weights of the people on the escalator, but that would be an interesting addition, yes. Now, ABB, for building automation, a slightly different concept, but if you go to some of the MEP, the mechanical, electrical, and plumbing catalogues that are used in building development, you can drill down, and if you're going through the electrical systems, instead of getting to a product like a transformer or a switch box or something like that, you can bump into an ABB software application that you click on in exactly the way you might click on to download a file to get, the Revit or the IFC version of, some component. And this software, okay, the implementation is that you do download it to your system in order to run it, but it helps you configure and choose and solve a design problem in the middle of the design process. And I think that shows something quite interesting about the way that industry networks are developing. Because, in the past, an industry network, there was probably an OEM that was the large company that kind of drove the networks that were feeding into that OEM. And the process involved a lot of personal contact, a lot of sales visits, a lot of qualification of suppliers by their customers. Actually, that process is changing, and it's changing where the participation in an industry network as a member of a supply chain, those decisions are going to happen online, and they're going to be driven by things like this ABB software inside an item catalogue. And you can imagine those catalogues changing into really quite intelligent sources of information that can interrogate what is on your system to help make decisions about what you should be using for the next step of design. Semiconductors. The money men are constantly talking about the stunning level of what they refer to as the secular growth drivers. So that means not just going up and down with the business cycle, but actually changing because of fundamental changes in demand. And at the moment for electronics, if you look at the growth in SSDs, in the amount of investment in cloud, the data centers that are being built to support cloud, automotive electronics on its own creates quite a demand. I don't know, have you ever done the sums, which if you try and take the value of software in a car, put the car manufacturers right up there with the biggest software manufacturers in the world? It's not really fair because they're not offering the software independently. Well, not yet, but at the moment, it's built into as embedded systems in the car. The demand for communications, just as that, but the change or the interesting thing and model for other industries is the success of the fabless providers. You don't need to have production facilities in order to be a successful semiconductor company. And, well, there are plenty of other examples of that. Made in China 2025 is an interesting one, because if one of the targets in there, where China is trying to move up the value chain in terms of, what goes on in engineering and manufacturing in China, the target of 70% of electronics consumed in China should be manufactured in China. Again, if you just project on that, it means almost all the new fabs to be built in the world between now and then should be built in China. Otherwise, that number just won't happen. So if we move on, machinery. Contracts, the Komatsu online system for their construction equipment is a good example. When manufacturing people, I don't know if you've ever tried to talk about IoT and they say, oh, you guys in IT, you invent a new acronym, we spend months finding out what you mean, and when we finally understand what you mean, we discover we've been doing it for 20 years. This is what they mean. Komatsu have been gathering data from construction machines for 20 years. It came to the public eye about 2 years ago when the Komatsu, one of the top table of management, talked about the surprise that they had had in how many people wanted to see this data. And it turned out that governments were asking to see this data because it told them the real health of the construction industry in their country. Okay, so you had to factor in a bit as to how successful was Komatsu in different parts of the world. But the nature of the thinking there is automation. And with the Komatsu's, what they call their smart construction sites, they've now added in the Skycatch drones. So I don't know if you've looked at Skycatch drones from California. They're integrating artificial intelligence, machine learning, different packages to handle kind of photogrammetric survey and interpret that information. And they're now at the stage where the frontiers are, the interpretation is being used to send instructions to the machines on the ground to automatically move the right soil from one place to another on a construction site. And they've already done the mapping of the site so that they can make those plans. That's an automated process from the drones. Fabricated metal, Trump, pretty traditional, but they offer software which will take you all the way through from inquiry to dispatch, not just software to tune and run the sheet metal machines. And when it comes to service, yes, of course, there's a huge service empire, but actually they've this thing called Axum, which I noticed because it's a very traditional German company that's chosen, or what they think is a kind of hipster name for a subsidiary. This is online service where the video feeds from the machines and an online access by an engineer to a machine can tune and solve problems on the machine. Look at software licenses. Obviously the growth of subscription and growth of pay-per-use, which is very visible in IoT-like applications, pricing based on message count and data volumes. But what I think is really interesting is the new cases coming up where software fees for design software are being covered by something different. So Buy From Us is one of them. That's been around for a while. So RS Components, the electronics distributor, you can just download Design Spark, which comes in a mechanical, an electrical, a PCB, and a safety option for free, because that design software works perfectly well, but it also makes it really easy to buy stuff from RS Electronics. By using our marketplace is, I think, well, it's not new to Apple. That was how Apple buys software. Using our marketplace means you get the development tools free. I want to tell you about an example of Buy From Us, another free design system like RS Components, Vention. Last year, Vention launched. You can use software on their website to specify machines that they will build, and you don't pay for the software. And yet it is enough of a CAD system to put together articulated mechanisms typically kind of tables and trolleys and frames and lifting devices. It can also include automated controls. So it includes a fairly modest level of software configuration to run controls on that system. And there was another example which I can't bring to mind at this precise moment, and I will tell you, oh yeah, a machine shop, where again, it's a free download in order to build design data that company can then manufacture for you. By using our marketplace, I think has, well, perhaps the most interesting example of that was one that I can't verify. It was printed in a respectable publication as a statement from a senior Dassault manager talking about the new marketplace in the context of additive manufacturing. And it was an off-the-cuff remark saying, perhaps one day you'll get our software for free so long as you sell the products that you design through our marketplace. And I don't know if you've seen the Dassault System marketplace, but they go through the whole process of qualifying suppliers, and they have the e-commerce system online so that you can use that system. Very similar to the announcements that Siemens has made about marketplace. And of course, royalties. Royalties, well, obviously software engineering is an important part of engineering software, the tool set these days. Pioneered by Oracle, I think, free tools so long as you paid the royalties on the Java runtime systems. And more people are offering software, embedded software, development tools for embedded software on this sort of basis. So, digital transformation, fertile ground for big consult, that reporting 17% growth in demand for those services. The result for engineering software is that the top table of management teams in most manufacturing companies now believe that a digital transformation should be part of their long-term vision. So they don't know how to get there. They don't know what the roadmap should be for the steps to get there. But if you go to the top management and talk about digital transformation, they say, oh yes, that's part of our vision for the future. And if you've got something to offer which shows them how to take a first step, they'll introduce you to the person who should be doing that in their organization. Okay, so global economy. These are numbers from the United Nations, Department of Economic and Social Affairs. They publish this thing called World Economic Situation and Prospect. So there are two solid lines there. They're based on two ways of handling exchange rates. The top one is using purchasing power parity, which is not market exchange rates. That's the bottom one. The top one is more like if you're bartering for goods, that's what you would see. And the interesting thing, on this chart, you can see the dotted lines, which are the same figures from last year, and the UN has had to nudge up its forecasts, which is an encouraging sign for the economy. And really, it means that after several years of a downtrend, 2017 is now looks like the fastest growth since 2011, and 2018 is forecast to be just a bit better than that. So if you look at what does this mean to a technology vendor? It means, here I've circled the 2018 numbers. That means if you don't do anything differently, that's what you should expect in terms of your actual growth. But that's only true if you're completely average, which means that your products are distributed across all industries, your sales resources are distributed that way, then that's what you can expect to see. 3% growth if you use traditional methods, 3.7 if you're lucky enough to have a price list in bottles of beer. Now, if you take that and look at the country level forecasts, probably a couple of things to say about this. First thing is I must point out the risks that are inherent in a map view. And the main one of that is that, of course, land area is not proportional to the size of the economy. So there you can see Greenland is huge. Greenland is not big when it comes to world GDP. And the size of the United States looks relatively modest on there. This is the old, whichever projection is, it's the one that Google Sheets has chosen to use for its maps. The other slight risk is that small country noise can actually affect the scaling of this sort of diagram, because if a small country has particularly large or small numbers, then it can distort the range that is being covered here. But you can visualize a couple of important points here. And I mean, I suppose the key point is the one that we all know, that China and India has quite darker colors here, strong growth across these 4 years, 2017 to 2020. I suppose I should point to the misleading one that's sort of at the right-hand side of Europe, because that is Ukraine. Comes out with very strong growth figures if you believe World Bank, OECD forecasts of what's going to happen in the economy in Ukraine. The one that I would put more faith in is Turkey, which is just down a bit south there from Ukraine, where after years of worrying about the Turkish government, I saw a couple of reports in February which said actually they seem to be doing things in a way that is more stable economically, even though it does involve a fair chunk of borrowing to keep the economy going, and it is putting Turkey as a whole up at the higher echelons of growth in GDP terms. So let's move on from that to try and look at countries and industries and engineering software. First point, the spend on engineering software is growing as a share of value added. Now, first question, what is value added? When you add up all the value added in an economy, it comes to GDP, gross domestic product. So, it's the components that you can look at an individual industry level. If you look at the ratio between the spend on engineering software and value added, set that ratio to 100 in 2012, and then look at the 2017 figures, it's grown across the board. So 112 overall, particularly automotive 126 and aerospace 118. Then there's some other sectors, and then a big sector, AEC, 109 in AEC. So, and that means that it's a growing priority for management teams, and it's growing faster than engineering software is growing faster than the economy. So let's try and understand that. So apologies that you can't read the text on this diagram. What we've got here is 112 industry sectors across the top. So there's a column for each industry sector, and they're arranged in terms of the size of the engineering software spend in that sector, from smallest on the left to the largest on the right. And the text that you can't read in the column, those are country names, 55 countries, and they're arranged from the smallest at the bottom to the largest at the top. So, no great surprises up at the top there, US, Germany, Japan, China, France, but you can immediately see, compared to the economy, China is second to the US in sort of standard GDP terms. In engineering software, Germany and Japan get ahead of China in engineering software spend. If we look at the verticals, and this is going from the largest and just moving across there, again, no great surprise. Automotive at the top, although that's only one of a number of automotive segments. So that is the actual manufacturer of vehicles, the kind of OEM spend, as opposed to the component providers spend. Public administration sometimes surprises people. The reason it's there is because this engineering software view includes geospatial and some of the public spend on that kind of mapping and related systems is quite substantial, and then aerospace and so on. So on this chart, we're not including EDA, we're not including embedded software development tools, but we are including all of the CAX technologies, PLM, BIM, and GIS. So I'm now going to fill this chart. And what these colors are, they go from green is small to red is large. and they are the compound annual growth rate of spend on engineering software at each of the country industry intersections. So there are 6,000 or thereabouts of those on this chart. And visually, of course, what you look for are the vertical lines, which means this industry is growing faster than other industries, and the horizontal lines, which means, if they are red, in both the countries as well, if they're red, this is growing faster than other countries. So let me try and pick out some interesting points. If you pick out those two sort of red or orangey lines near the top, well, no surprise, China and India. Probably worth pointing out that Japan, which is one of the big engineering software spend countries, is pretty much straight greens for this forecast for the next 3 years, which is, Japan in some ways is teaching the rest of the world a lesson about how to manage an aging population and a stable GDP, and just changing what it does in certain ways. So it's the place to go if you want to look for automated healthcare equipment for use at home. Let's move to look at another country, but the US in more detail. Now, in this one, this is the fastest growing sector in the US. And it's a slightly unusual one, manufacturing of refined petroleum products, which is actually quite a small sector. And the reason it's a small sector is that this is the actual manufacturing. So what it implies is more in-refinery type use of engineering software, which does seem possible. Maybe, asset management is changing. Are people using engineering software more for repair and so on? Look at the next, they're not quite so red. These are the oranges and yellowish sectors for the US. And I think of the next 6 sectors, let me pick out 2, because these are the 2 that are unique to the US. If you look at the other 4, they're actually, at the top of a column, which is largely reds. Specialized construction of roads and railways, construction of buildings, architectural consultancy. That's quite worrying, because you think construction had a bit of a nosedive in 2011. If you think of the way that Caterpillar were reporting their results. So it is reassuring that actually in 2017, Caterpillar reported revenue growth of 22%. John Deere reported 12, maybe it was 16, 12 or 16, 12%. And so it's kind of corroboration that there are positive moves there. So if we look at a sector, motor vehicles, what are the countries there? Well, again, just picking out the largest growth countries, and you can see the German investment in Eastern European type countries coming through. They're moving up the value chain. From these numbers, it would appear that the investment is pushing more into the design level and not just where it has been, which has been production only. So if I look at application categories, there's the big picture. And I suppose the interesting numbers, 6.6% for 2017, 9.2% for 2018. They're actually, those 2 numbers are slightly lower than this time last year. I stood here and forecast for 2017 and 2018 by 0.8% in 2017 and by just about 1% in 2018. And I think the reason there is that some of the growth that we're seeing in the GDP numbers is actually in service sectors which are not great consumers of engineering software. So, if the travel sector does well with tourism, hotels do well, Airbnb does well, doesn't make much difference to engineering software, but it does make a difference to GDP. And I think that's one of the factors in that difference. If we look at the individual sectors, so this is excluding EDA. You can see that the definitions here, PLM includes all the CAX product, BIM, GIS is the and visualization, and then the blue one, Cs, is a Kambashi term, systems engineering and engineering software and embedded software development tools. If I put up the chart, the growth rates for each of those sectors, you can see that BIM is the standout sector. And we've already seen the construction side of that. There's another factor there, which of course is Autodesk emerging from its first year of mandatory subscriptions. And as it gets through the rebound effect from having had the total revenues, these are revenue numbers, having had revenues reduced because of the licensing, as those licenses kick in and people pay, this year, next year, the year after, the year after, the year after, then we will see some of that effect. And I think that's probably some of, I was about to say half construction, half the Autodesk subscription effect in those 2018 and 2019 BIM figures. Please don't quote me on the half. I kind of estimated that on the fly right now. And there's electronics, just to put a scale on it. I suppose interesting point here is that without EDA in 2017, if you include EDA and sort of project the line across, you can see that in 2020, the rest of the engineering software market will have grown by the total size of the substantial EDA software market. So it's a health market. If you're going to gain share, you're going to be having to grow in double-digit figures. And I think that's about it, really. The key message is the silos are changing. Well, not many country boundaries, but industry boundaries, technology boundaries, and especially licensing and who pays whom for what. And that's it. Thank you very much.